Two special types of functions are even functions and odd functions. And the straightforward definition for an even function means that if I take f of negative x, I'm going to get back f of x. I get back the original function. An odd function means if I take f of negative x, I actually end up with the opposite of f of x. I get back everything opposite to the original function. I can do a test for these visually too in some cases. If it's an even function, it should have y-axis symmetry. It's going to fold along the y-axis. If it's an odd function, it should have origin symmetry. Okay, it's going to be that double fold or 180 rotation. So again, the algebraic test, I do just one test to determine both even and odd. I'm going to take f of negative x. And if I end up getting the same thing, that means even. The words same and even kind of go together in my mind. You know, if I treat everybody the same, I treat everyone evenly, kind of makes sense. And if I get back the opposite of my f of x, that means I have an odd function. And I like this one because their O's go together. So even means f of x equal f of negative x will give me back the original, the same function, and its y-axis symmetry. An odd function means I'm going to get back the opposite of f of x, and I'm going to have odd origin symmetry. All right, so let's look at some pictures. And just these three pictures here, if I'm just eyeballing it, yeah, it looks like I could fold that on the y-axis, so that would be my even function. This one, well, I'm not even going to talk about even, odd, or neither, because first of all, it's not a function. And how do we know that? The vertical line crosses more than one time, so we'd have to say it's neither. This one, if you fold it over the y-axis, no, that's not going to line up. But if you rotate it, or if you fold it over the y and then over the x, it does line up. So that's origin symmetry, meaning that we have an odd function. A couple more examples. What if they don't give me the picture, they give me the function itself? Okay, so negative 3x cubed plus 7x minus 1. Well, let's test this algebraically. Again, that means I take f of negative x, so each one of these x's gets replaced by a negative x. When you cube a negative, you get a negative, so a negative times a negative makes this first one positive, the first term. Positive times negative, we get a negative 7x in the middle, minus 1. Now we're going to compare this answer to the original one. You notice that the first terms, they're opposites, okay? Second terms, yep, they're opposites. But this third term, they're the same. So this is not exactly the same, it's not even, and it's not exactly the opposite, so it's not odd. We'd have to say it's neither. The nice thing is you can confirm this with your calculator. If you go ahead and you take this function, you put it into your y equals, and hit your graph, you'll notice, well, yeah, that it almost kind of looks like origin symmetry, but you notice that this side over here on the left, that dip, is a little bit bigger of a dip than this is over here, a rise. So it's not quite origin symmetry. All right, what about f of x equals 5x to the fourth minus 3x squared plus 6? Same test, f of negative x, so each of these x's got replaced by a negative. If you take a negative to an even power, you're always going to get a positive. And so we get 5x plus 3x squared plus 6. This is identical to the original. It's the same as the original. That means I have an even function. Once again, on a test, you could confirm that by quickly graphing this in your calculator and seeing that you had y-axis symmetry.